Welcome back. Thank you for joining me for our day 2 of these 5-1 notes. So in the first part, we were talking about classifying polynomial functions, talking about naming them based on their degree and based on the number of terms that they had. Today, we're going to analyze another aspect of these graphs. We're going to aspect what's called their end behavior. What the end behavior means is the directions of the graph to the far left and the far right. So essentially, what are they doing when x is going to negative infinity and when it's going up to positive infinity? So let's start with two graphs that you guys know pretty well by this point. So y equals x squared and y equals x cubed. Okay, now I provided the graphs here for you so you can see exactly what's going on here. So if you look at the ends of these graphs, notice for y equals x squared, notice the end is going upward to infinity and this side is going upward as well. So looking to the left and the right, both sides are going up. So this is called an up-up end behavior, okay? Now, there's another way of notating this. So I also want you to be familiar with this type of notation right here. So as x is going to negative infinity, so negative infinity, think of as left. So to the left, what is the function doing? The function is going up to positive infinity. All right. Positive infinity means going upward. All right. So as x is going to infinity, well, to x, positive is to the right. So essentially think of that as going to the right. Okay. What is the function doing? Well, the function is still going upward to positive infinity. Okay. So I do want you to understand both types of notation. When we say up, that means infinity. When we say down, we're talking about negative infinity. All right. Now, for x squared, both sides are going upwards. Now let's take a look at x cubed. So x cubed is a little bit different. To the left, notice what's happening to the left. Our function is actually ending up heading down forever. All right, so this time that when x is going to the left, what's the function doing? Well, the function is actually going downward. And as our function is going to the right, on the right-hand side of the function, what's it doing? Well, it's going up. And again, up meaning positive infinity. So really all we're doing is looking at what's it doing to the left, what's it doing to the right. Okay? Again, we're starting with two functions that hopefully you guys are pretty familiar with. Now, of course, we have to spice it up a little bit. So we're not just going to leave it at x squared and x cubed. I also want you to think about, well, what happens when we have the negative? Now, we know that negative means an x-axis reflection. So notice what's happening. So our y equals negative x cubed. Notice this time, both are going downward, okay? To the left and the right, the function is heading down forever. So to the left, what's it doing? Well, it's going down to negative infinity. And to the right, it is also going down to negative infinity. All right, now, what about x cubed? Well, same thing. It's flipped from what it was before. So notice this time, to the left, notice it's going up to positive infinity. And to the right, it is going down to negative infinity. Okay? So these are four basic structures that I want you to be aware of. And the reason I'm taking so much time to talk through these four is because these are critical to understanding higher power functions. So before I switch to the side, please make sure you have all of that written down. And now I want to show you every polynomial of even degree will act like y equals x squared. Okay, so y to the 4, y to the 6, all of those will act like y equals x squared. And every degree of odd, or every polynomial of odd degree will act like x cubed. Okay, now what do I mean by that? Well, let's take a look. To analyze end behavior, identify the term with the highest degree. Notice if it's negative or positive, and draw a rough sketch of the appropriate y equals x squared or y equals x cubed. Now, this is a little bit different because for these ones I've actually provided you with what the equations or what the graphs actually look like. But I'm still going to show you how to draw the sketch just so you understand how to do this for the test. Because on the test, I will not be providing the graphs for you. So let's say I give you this polynomial right here, and I'm asking you, describe the end behavior. Okay, now obviously again, you can see what the graph actually looks like. However, what do my instructions tell you to do? Tells you to identify the term with the highest degree. So in this case, x to the 4. That means this is going to look like an x squared, okay? Because 4 is even, so it's going to follow the x squared pattern. And it is positive, okay? So that means if I'm drawing my rough sketch, that's all I mean by a rough sketch, okay? Understand that a positive x squared function is going to look like that parabolic shape facing upward. And what is that telling us? Well, it's telling us the end behavior of up and up. Now, again, just to reflect so you understand, isn't this graph showing you exactly that same behavior? So that's what I mean by you can just draw a rough sketch of y equals x squared, and every even polynomial with even degree, all of them are going to act exactly the same way. Okay? So that's all I mean by focusing on that first term. So it's going up to positive infinity and up to positive infinity. All right, looking at our next one. So again, if I were to just give you that polynomial right there and ask you, what is this end behavior? You need to identify the term with the highest degree, negative x squared. Okay? And again, I've given you the graph, but ignore that for a moment. So just focus on that first term. Now here it actually is a negative x squared, okay? So you already know the basic shape of that graph. This time is going to be a parabola facing downward, okay? But again, if it were any even exponent, you know that's how it would act. So when I'm analyzing this behavior, I'm seeing down and down, just like the real graph is showing me. So again, that's the power of these little rough sketches, so you can see what the real function is doing. To the left is going down to negative infinity, and to the right, it is also going down to negative infinity. All right. Now, our next one. So, we're given that polynomial. And again, we search for the term with the highest exponent, the term with the highest degree. And I see that it's an x cubed. Now, again, that's one of the basic ones that we know. However, every odd function will act that way, every odd polynomial. So, Now, I also want you to notice that it is negative, so it's going to be the opposite of x cubed. It's going to face the opposite way. So instead of going like that, like we know x cubed does, we know is actually going to be giving us the reverse shape. So again, those are the types of thoughts I need you having. I need you to be able to draw and think about that really rough sketch. Because notice what's happening. We have up behavior and down behavior with our rough sketch, just like the real graph does. So what's it doing? Well, to the left is going up to positive infinity. To the right is going down to negative infinity. So that's how I need you thinking about these, okay? Being able to draw those rough sketches and analyze what the end behavior looks like. Now, in summary, I do have this little table for you, but again, there's no need to really memorize this table because if you can draw that sketch for me, you can determine anything, all right? So again, this is just for your benefit, but don't feel a need to memorize this table because as long as you can make those sketches, you're going to be able to visually see the end behavior and not have to memorize up, up, down, down, up, down, and down, up. Now, I do want to discuss graphing polynomials as well, okay? So we've talked about analyzing end behavior, but now I also want to talk about actually graphing them. So the emphasis of this part is going to be graphing cubics because you know how to graph linear things, you know how to graph quadratics. So let's talk about cubic polynomials. Now, the traditional way, the long way of doing this, what you could do is make a table, okay? So step one, they would ask you to make a table. Start choosing some x values, plug those in to get the y values, okay? After getting those points, you would actually plot those points. So you get that point there, you get that point there, that point there, there, and there. And that gives you enough information to sketch the curve, okay? And then step three, kind of wrapping back to what we're talking about today, this end behavior analysis. Well, what's it doing to the left? Well, to the left, I see it going down to negative infinity. And to the right, I see it going up to positive infinity. Okay, so some very important things there. Now, again, this is a long, drawn-out way to graph cubics. And sometimes it can be really hard to tell because cubics can get pretty curvy in there. So I'm going to show you a better way. I'm going to show you a way to graph any polynomial with ease, okay? So what you're going to do in order to graph these is go to your calculator, okay? So a much easier way of doing this is by simply going and using the calculator functions. So now I realize some of you don't have these at home, but if you do have a graphing calculator at home, please be following along with me. If you don't, then you're going to have to work with it in class and pick up on this just using class time. But again, if you have one, please have it out and be using it. So now we are looking at y equals 3x minus x cubed. All right. So now I have a little emulator here to show you how to use this calculator. Okay. So what you're going to do, the first instructions say go to y equals. So I click y equals and a screen like this should come up. Okay. So it's asking you for your first function. So, and the function we want to graph is 3x. Now, do you realize that that button that's still highlighted red, that is your variable. So if you've never graphed before, that button right there is how you get your x, okay? Then minus x cubed. Now cubed is in the math function. Then I scroll down, oh, sorry, and hit enter to get cubed. Again, little stuff like that, if you forget, just ask me right away in class and I can refresh your memories on how to get to that cubed button. But the important thing is you type your function in right there, okay? So we have 3x minus x cubed, just like we should. All right, so next thing I'm going to do, I'm going to graph this. And notice, there it is. I have my graph. So this is a much easier way of getting that information, okay? Much easier way than plotting all those points and trying to graph this out is getting it just like this, all right? Now, throughout this chapter, I'm going to be showing you all of the techniques, all of the tricks of the trade for these graphing calculators. So if possible and you don't have one, please, please get one because it is going to very much benefit you to have this during this next chapter and from now on in class because I'm going to be teaching you a ton of calculator techniques. All right, so back to this. So you saw that's the graph that you got, okay? Now, let's analyze its end behavior. So to the left, it is going up to positive infinity. To the right, it's going down to negative infinity. All right, now, we're not going to focus on this too heavily yet, but I want to introduce you to a vocabulary idea that we're going to come back to. This point right here, and that point right there. Now, you may be thinking, that's kind of like a little parabola right there. Is going here, is going down to a minimum point and then coming back up. So that's why we call that a relative min. It's not an actual min. The function can be higher and lower than it, but it is a relative min for that little area. And then here, notice it's going up to a maximum point and then coming back down. And so we're going to call that a relative max. Now, again, I'm just introducing you to that vocabulary at this moment. We're not going to do anything with it quite yet, okay? We're going to wait till next section to actually work on it, but I want you to at least be familiar with the idea of it. Now, to end this section, we're going to look at this. So, I give you a polynomial. Before I graph it, I want to determine the end behavior. So remember, we have that negative 2x cubed. That's the term with the highest degree. So a negative x cubed, well again, a normal x cubed would be rising like that. So the negative of that would be doing the opposite behavior. Would be coming down like that. So remember, when I ask you to determine the end behavior, what you can do is just draw that really rough sketch. Then see on the left-hand side, what is it doing? Well, it's going up to positive infinity. The right-hand side is going down to negative infinity. Okay? And just a little stuff about naming to remember what we did yesterday. So naming based on degree would be that cubed right there, that 3, meaning it is a cubic function. Based on number of terms, well, I see 1, 2, 3 terms. So that means it is a trinomial. Okay? So let's not forget those couple things. Now, let's go and graph this using a calculator so you can see another time just how to use these calculators. So I'm going to go back to the y equals, okay? Now, I already have a function in here, so I'm just going to clear that function out. Okay, if you already have a function there, you don't want it anymore, just clear it out. So now I'm going to start typing in my new function. So I have negative, oh, forgive me for a moment. I apologize for that. My screen wasn't letting me hit the minus button. But negative x, or sorry, negative 2x cubed plus 4x minus 1. So again, in the y equals, all you need to do is type in your function. Then hit graph, and that's what you get. All right? So now, again, if I'm ever asking you to sketch this, like at the end of this, I said use a graph and sketch your answer. Okay? For sketching it, all I'm really looking for is, again, very, very rough sketch of what's going on. All right? So as you're looking at your calculator, you can see how it's coming down, crossing in between here, then coming back up, crossing here, coming back down. So when I say sketch, I don't mean actually draw a thorough graph. I just mean sketch appropriately what it looks like so you have an idea of what that graph looks like. Okay? So thank you for joining me. I apologize this got to be a little bit longer video, but there's a lot to cover when we start talking about the calculator techniques. But thank you for joining me. Please make sure you have all of this written down, and then we will do our practice work in class.